Hello, this is not your chem tutor, and in this video, I will teach you how to find the empirical formula from mass percent composition. So before you continue this video, you should have watched my other video where I talked in detail the step-by-step process in determining or solving the empirical formula. Because in this video, I will not go into very much detail, so I will just answer examples in this tutorial. So if you want to check out or if you want to learn the step-by-step process on solving the empirical formula, I will link the video in the description box. Please check it out. Okay, so as what I've mentioned, we will be determining the empirical formula from mass percent composition. So for example, sulfuric acid contains 2.06% hydrogen, 32.70% sulfur, and 65.25% oxygen. What is its empirical formula? So I'll give you a tip. Whenever you are given mass percent composition, what you do in step 1 is you just replace the percent with grams. So for example, if you have 2.06% hydrogen, you just replace it. You replace percent with grams, so that becomes 2.06 grams of hydrogen. 32.70% of sulfur is 32.70 grams of sulfur. 65.25% of oxygen is 65.25 grams of oxygen. So that's for step 1. Again, you just replace percent with grams. For step 2, you need to solve the moles of each element. So I already taught you on how to do this in my previous video. So again, you can check that out if you still don't know the process. To get the moles, that is just equal to mass divided by the molar mass. So let's start with the moles of hydrogen. So the mass of hydrogen in step 1 is 2.06 grams. Divided by the molar mass of hydrogen. In the problem, it's already given 1.008 grams per mole. So in case it's not given in the problem, you can get the molar mass from the periodic table of elements, okay? So if you solve this in your calculator, the moles of hydrogen you'll get would be around 1.99 moles. Now let's move on to the moles of sulfur. So we are given the mass of sulfur, 32.70 grams, divided by the molar mass of sulfur in the problem is 32.07 grams per mole. So if you solve this in your calculator, this will give you 1.02 moles of sulfur. And lastly, we have oxygen. So moles of oxygen, the mass is 65.25 grams divided by the molar mass of oxygen is 16 grams per mole. And if you solve this will be equal to 4.08 moles of oxygen. And remember the third step, as what I've taught you in the previous video, you will put the moles you have solved as the subscript of the element. So in the previous slide, in step 2, we got 1.99 moles of hydrogen. So you put 1.99 as the subscript of hydrogen. We have 1.02 moles of sulfur. You put that as the subscript. And then 4.08 moles of oxygen. So you also put that as the subscript. So for step number 4, if you can remember the steps, you choose the smallest subscript. Among the 3 subscripts, the smallest is 1.02. So what you do is you divide all the subscripts by the smallest one. So you divide 1.99 by 1.02. You do the same thing, 1.02 over 1.02, and 4.08 divided by 1.02. So 1.99 divided by 1.02, that gives you approximately equal to 2. So H2. 1.02 divided by 1.02 is 1. So S1. 4.08 divided by 1.02 is equal to 4. So O4. So we got H2S1O4. In chemistry, we know that if the subscript is 1, we omit 1 as the subscript. So this is simply H2SO4. And this is the empirical formula, and this is the answer to the question. Okay, moving on to example 2. Magnetite is 72.36% iron and 27.64% oxygen. What is its empirical formula? Again, when you're given mass percent composition, the very first step, or your step 1, is to change percent into grams. So 72.36%, you change that to 72.36 grams of iron. We have 27.64%. You change that to 27.64 grams of oxygen. That's step 1, very simple. Step 2, again, you determine the moles of each element. That's mass divided by molar mass. Starting with iron, so the moles of iron, the mass is 72.36 grams divided by the molar mass of iron given in the problem is 55.85 grams per mole. And if you solve that in your calculator, that's equal to approximately 1.296 moles of iron. Then, we solve for the moles of oxygen. The mass is 27.64 grams divided by the molar mass given in the problem is 16 grams per mole. And this gives you around 1.728 moles of oxygen. Again, the next step would be to put the moles you got from step number 2 as the subscript of the element. So in step number 2, we got 1.296 moles of Fe, so that becomes the subscript of Fe. We also got 1.728 moles of oxygen, so that becomes the subscript of oxygen. In step number 4, we choose the smaller subscript. So in this case, the smaller one is 1.296 and divide everything by that smaller number. So 1.296 divided by 1.296, that's equal to 1. 1.728 divided by 1.296, that's equal to 1.33. So remember the rule I taught you in the previous video. Whenever you have decimals like 0.5, 0.33, and 0.67, the rule is you do not round off. So you put them as is. So if you got 1.33, you put 1.33. And in step number 5, we will get rid of the 1.33. How? Again, I taught you in the previous video, if you have 0.33, you multiply all the subscripts by 3. So you do 1 times 3 and 1.33 times 3. So 1 times 3 is obviously 3. 1.33 is equal to 3.99, and that's approximately equal to 4. So the empirical formula of magnetite is Fe3O4. And this is the answer to the question. Okay, so for our last example, a compound is made of carbon, hydrogen, and oxygen. It contains 40% carbon and 6.71% of hydrogen. So what is its empirical formula? So again, the first thing you'll notice in this question is that there are 3 elements given, but there are only 2%, 2 mass percents given. There's no mass percent given for oxygen. So that's the first thing you need to find out. What is the mass percent of oxygen? So remember, when you add all percents, that should be equal to 100%, right? So in order to find the percent of oxygen, that is just 100% minus the mass percent of carbon, which is 40%, minus the mass percent of hydrogen, which is 6.71%. And if you do this in your calculator, you will get 53.29% of oxygen. So now that you have all the mass percents of the elements, you can now proceed to step 1. Again, what I've told you in the previous examples, you just convert the percents into grams. So 40% of carbon is just 40 grams of carbon. 6.71% of hydrogen is just 6.71 grams of hydrogen. 53.29% of oxygen, which we just solved, is 53.29 grams of oxygen. Then step 2, you get the moles. Moles again is mass divided by molar mass. So moles of carbon, the mass is 40 grams. The molar mass is given in the question, 12.01 grams per mole. And this is approximately 3.33 moles. Then moles of hydrogen. So the mass is 6.71 grams. The molar mass given in the problem is 1.008. And this is approximately equal to 6.66 moles of hydrogen. And lastly, for oxygen, the mass is 53.29 grams. The molar mass given in the problem is 16 grams per mole. So 53.29 divided by 16, that's 3.33 moles of oxygen. Again, for step number 3, you just put the moles as the subscript of the elements. So for carbon, we got 3.33 moles. For hydrogen, we got 6.66 moles. And for oxygen, we also got 6.66. For oxygen, we got 3.33 moles. For step 4, you choose the smallest number of moles. In this case, it's 3.33. So you divide everything by 3.33. So obviously for carbon, that's 1. For hydrogen, 6.66 divided by 3.33, that's 2. For oxygen, that's 1. Again, in chemistry, when the subscript is 1, you just omit 1. So this is simply CH2O. So this is the empirical formula and the answer to example 3.